Before I go any further, I must warn you that once you taste the beauty of Lambda expressions, you will never go back. So you would probably hate your job because, at your workplace you still use Java 7 or even 6. Many companies still do. So you may say, why didn't I take the blue pill? So those who are brave enough to take the red pill, then keep watching this video, otherwise stop now. Are you still there? Okay, good. I'll give you the details of Lambda expressions. So what is the type of Lambda expressions? I talked about blue pill and red pill, but that was ridiculous. I mean, the people using some other languages, they have been using Lambda expressions for years. So we are just too behind. Well, at last we can catch up. So what is the type of Lambda expressions or anonymous functions in those languages? It's usually function type, first class citizen function, and Java doesn't have it. So that means it has to be added to the language, and then it would be really hard because we have to think about the relation between that new type and then all the types, including generics and covariant, contravariant and things like that. And also that there is no VM level representation of that new type, new function type. So that means it requires significant VM change. So instead of doing something may lead to unknown consequence that might not be that might be unsolvable. What was chosen was using something we've already got. So what is that? Well, Java doesn't have a function type, but we often use function objects, right? So for example, we use comparator function object to compare some values, and when you sort, we pass that collection to sort method with comparator, right? And we also use runnable and callable, for multi-threading. So why don't we just use the type? So the type of Lambda expressions in Java is a functional interface type. And what is a functional interface? It is an interface which has a single abstract method. Or isn't every method in the interface abstract? Isn't it just redundant to say single abstract method? Well, it was true before Java 8, but from Java 8 you can have a static method in the interface. That means you can probably create a utility interface just like a utility class, or you can have a static factory method in the interface. And it's not the end. There is an even more surprising news. Now you can have an implementation in the interface. That means you can have a method body in the interface. Does that mean Java now supports multiple inheritance? Yes, it does, but I'm not talking about it right now. I will when I talk about default methods. So single abstract method. So if an interface has a single abstract method, that's functional interface type. So here are some examples. So this one, the first one is functional interface because it has only one single abstract method, right? But these are not. Second one has no abstract method, and then third one has two. So if I have this kind of interface, and if I want to create an object of this type, then I can use Lambda expressions, right? And as you know, in the JDK there are lots of functional interfaces. So and in Java 8 you can easily find those interfaces are annotated with this add functional interface annotation. So what it does is telling the compiler this particular interface is a functional interface, so validate if it's correct one. So then what compiler does is checks if that interface has one abstract method, then it compiles. Otherwise it will give you a compile time error. So for example, if I put add a functional interface annotation here, then it will compile without any problems. But if I put it here or there, then I will get a compile time error. So well, that means you know, you can use lambda expressions without putting that add functional interface annotation, but if you do that, then, you know, compiler checks if that is actually a functional interface type or not. Okay, so in Java, yeah, this is a typical one, as I said, comparator. So this one has a single abstract method, so it's a functional interface. It even has that add functional interface annotation. So that is very typical one. But before Java 8, to create an instance of this kind of type, what we needed to do? Well, ugly anonymous class object, right? We had to do this, full of ceremony, boring, noisy, right? So I'll show you how to convert that comparator, that anonymous class, into lambda expression. So if you just think about syntax, nothing but just syntax of lambda expressions, it's more like removing ceremony from an anonymous class object, right? So yeah, as I said, this is what we usually do when sort collections in Java. So you pass this product list to this collection sort method, and we did this comparator on anonymous class object. So I'll work on that one. So I'll convert this comparator into lambda expression. So think about the most important part of this code. That is just this method body, right? That's where the actual comparison happens, right? So that's the most important part, and that's also what I'm most interested in, right? And what about the parameters? Oh, these are important too, because, well, so that I can know, you know, if I should have parameters so that I can know that what parameters I can use, right? Now I have P1 and P2. So these are important. What about return type? It is important, but not as important as the other two, because then I can check the compare to method, I mean return type of compare to method, to then find out what is the return type, right? So it's important, but not as important as the other two. Now think about the ceremony part. Well, this one, why do I need to create an object just to pass this logic, right? That's because Java didn't have a first class function. That's why. So that's ceremony, remove it. What about override public and then method name? These are all ceremony, and I don't care the name of that method. What I do care is only this part. So remove these two, and now I have return type, parameters, and then method body. And I already talked about that. You know, return type is not as important as the other two, because I can anyway get the return type by checking the return type of compare to method. So remove that too. Now I have parameters and method body. Now if I just put hyphen and greater than sign, it becomes lambda expressions. But I can even go further. So what about this input type? Input parameter types. Well, when I pass the products list, I already, you know, specify the type. It was the list of a product. So type is already known, and I don't need to repeat it. So remove that. Now I have, the name of parameters without type information, and then method body, but with curly braces, return keyword, and then semicolon. Do I need to have these? Well, in this particular case, there is also ceremony. Why? Because, you know, what can I do with this single line of code? I mean, it is two lines, but I put new line there to, you know, present that, you know, one line of code in this small screen, but it's actually one line of code. So what can I do? Well, I mean, what else can I do? Well, you know, with this one line of code, well, rather than returning int, value, can I do something else? I cannot. Well, what I can only do is returning int, right? So I don't need to say that I return something. I don't need to wrap it with, you know, curly braces. It's just one line of code, so no semicolon is required. Remove them. Now this is very simple, concise, elegant lambda expression. Okay, it's very simple. You have a name of parameters and then what you want. That's it. So, but this is only one case. You know, the lambda expressions requiring two parameters, right? And then body returns something. So what about, you know, that lambda expressions with one parameter or no parameter, more than two parameters, or body returns nothing, or lambda body has more than one line of expression. Okay, I'll explain all those cases. So lambda expressions consist of three parts: parameter, arrow, lambda body. So it's more like an anonymous method without a name. So on the left hand side of the array, the arrow is parameter. On the right hand side is lambda body. The first case, it takes no parameters, so you just put parentheses without putting anything inside, and then arrow, then lambda body. This one returns nothing, it just print that hello world. And the second case, it takes no parameter, the same thing, but it returns string. So if lambda body contains only single line of expression or method invocation, then you don't need to put curly braces and a semicolon or return. It's very simple, just like that. And this one, third one, it takes one parameter and it has type information. The type of parameter is product. And on the right hand side, it checks if that product is null or not. If it's not null, then return true, otherwise false. So the result of this lambda expression is Boolean. Next one, it takes only one parameter, but it doesn't have type information. Most of the cases we know the type already, right? So we don't really need to repeat that again. That's just redundant. So it has actually same method body as that one. Okay, only difference is it doesn't have type information. Next one, it takes one parameter, no type information, but now it has curly braces, return, and then semicolon. Once you put curly braces, you have to put return and semicolon. It's just like normal Java code. The last one, the most concise one. So if lambda expressions takes only one parameter, then you don't need to put parentheses. You can omit that. So without parentheses, you just put the name of parameter and the arrow, then lambda body. That's it. Next, having two parameters. So lambda expression takes two parameters. Here I have P1 and P2, and also it has type information and one line of code. As I said, I put new line there, but it's because of the small screen. It's actually one line of method invocation, so you don't need to put any curly braces, return, or anything like that. And the same thing, exactly the same thing, only difference is it doesn't have a type information. Okay, again, most of the time types are already known, you don't need to repeat that. It's just redundancy. Okay, simple. Okay, final example, it has several lines of, if lambda body contains several lines of statement, then you need to put the curly braces inside the curly brace. These curly braces is just same as normal Java code. You have to put semicolon and return keyword. It's just same as normal method body in Java. It takes only one parameter there. Yeah, nothing so special. Alright, now I'll demonstrate. I'll give you more examples. Java 8 has some few new functional interface types which are really useful, and why these are useful would be clearer when I explain Stream API and when I give you more examples almost the end of this video. So here I'll just use those types, and I'll use lambda expressions to create objects of those types. So first one would be supplier, second consumer, then predicate, finally function. So supplier supplies something, so it takes no parameter and returns some type T. Consumer consumes something, which means it takes some type T and returns nothing. Predicate runs some test on given input T and then returns Boolean result. And function, it takes some type T and returns another type R. It's just like mapper that I showed you in here, right? just like this. Okay, so those are functional interface types, and I'll show you how to create objects of those types using Lambda expressions. First, supplier. Let's say I want to have a supplier of a string, so that supplier returns some string value. Let's call it name supplier, and in there the supplier, as you can see, it takes no parameter and returns some value, and that some value is string value. So it takes no parameter, which means I just do empty parenthesis and then arrow, then returns some string value. Here I put my name, Kevin. Okay, so to see if that works, print it out. What I do is name supplier and then get. So I should get Kevin, right? Let's see. Yep, I got Kevin. Alright, that's simple. Next one, consumer. So consumer of let's say consumer of integer, and let's call it number printer. And what it does is as you can see, consumer that has one abstract method which takes some type t input and returns nothing. So take some type t, here is integer, let's call it I, and then returns nothing. So what it does is it prints something, and I just put something more like this. Yep. So it gets integer and then print number equals and then that integer. So to see that, just do this number printer and then accept, and 100. I should get number equals 100. Run it. Yep, I got that, number equals 100. And in Java 8, the JDK has the collection interface in JDK 8 has that for each okay, not here, that's iterable, I guess. Yeah, in iterable, yeah, it has for each method which takes consumer. So if I just use that, and I can use that consumer and then ask that collection itself to iterate over that collection, and then get each element and do something on it. So I can do that. So here, let's just create a list of integer 2, 3, 4, 5, and then do what I want to do is for each, and then I just pass that number printer, and what I should get is number equals 1, number equals 2, number equals 3, number equals 4, number equals 5. Run it. Yep, I got that result, right? So because this takes consumer, so I could just pass that, and I can also do this instead of doing passing that parameter, the variable. What I can do is I can just write the Lambda expression there. So I'll just copy and paste like that and run it. Yep, same result as the previous one. Okay, so that's for consumer. Now predicate. So predicate of, let's say, integer again, and then what should I say is greater than 5. And what it does is it takes integer and then it should return the boolean result. So see, it takes some type t and then returns boolean. So here I said greater than 5, so do that. I should be greater than 5. And if I run it with greater than 5 and then test, here I say 3, then 3 is not greater than 5, so I should get false, right? And now test with 7. 7 is greater than 5, so I should get true. So result should be false then true. Run it. Yeah, I got false and true. Okay, it's working. Simple. And finally function. So function is just like my function, so I'll use my old example. So get some type t and returns another type r. So it's just like the mapper. So I get the type of product and then returns string, which I okay. in the beginning of this video, what I wanted was well, the names of products, so I should call it product to name mapper, and here I do product, then get product name, right? Done. And then to name mapper and apply. Here I pass the product 1, and what is the name of product 1? That's A, right? So name of first product 1 is, its name is A, so I should get A there, right? So I just print it out, run, then I got A. So I also use this map method, okay, and then pass that function object created using Lambda expressions. So what I do, okay, print it out, and then map products, and then pass that product to name mapper, and then I got error. Yeah, so because this one takes function 1, not the function from JDK, not this one, you know, from the java.util.function package, not that one, but my own function 1. Just so let's forget about this one now, then make it function. And then if I run this, I now have even more problems. Yeah, because you know, okay, these use that function 1 type, so just comment it out. Alright, it should be fine. I should get what? A, B, C, D, E, right? Run it. Yep, I got A, B, C, D, E. It works. Okay, that's good. So I can do that, or I can well, I can pass this variable, or I can do this. Just writing Lambda expression here, product.get name, and run it. Yeah, same result, right? Okay, and I also should explain more about the parameter part of the Lambda expressions. So to explain that, I should create comparator object. So comparator, and let's say it takes big decimal, and let's call it big decimal comparator. And what it does is it's just, you know, comparing to big decimals. So here I have not big decimal, sorry. The comparator has a method called the compare to, and it takes, you know, 2 t types. So in here is that t is big decimal, so big decimal 1, let's call it big decimal 2, just simple. And here nothing special, it's big decimal 1 compare to big decimal 2. That's it. It's fine. And oh sorry, BD2. It's simple, right? Now what happens if I add type information here, big decimal BD1? Then I have some compile time error. It says syntax error on token big decimal, you know, then opening parenthesis expected after this token. Well, why do I have this? Well, because you specified type of just one parameter, then Java complains. If you do this, then Java says, well, I've provided these beautiful Lambda expressions, then what you just did was opening door to ceremony, then you deserve even more. So you have to specify every single type of parameters. Okay, so you have to do that once you okay, typo. Okay, now it's fine, right? So you cannot just specify type of one parameter. If you do that, you have to specify type of every single parameter. Alright. Here it added final because, you know, my Eclipse did it because, you know, immutability is better than mutability. But well, this is fine too. So here, once you specify the type, then you specify type of every single parameter, which is not good. As I said, you don't need to do that because I have type information here. You don't need to specify that again. Okay, that in Java 8 compiler is not that stupid anymore. Yeah, it was a bit stupid. I mean, you know, in Java 7 and 6. I mean, before Java 8, it was kind of stupid, but now it's not that stupid anymore. So you don't need to specify that. Alright, good, like that. And let's just test it. So big decimal comparator, and I pass what? Compare. Then here okay, 10, big decimal 10 and big decimal 11, and I should get what? -1, right? Because then 10 is less than 11. So I didn't put it out. Okay, alright, I should get -1. Yeah, -1. Yeah, it works. Good.